We are continuing section 1.8, which was the combination of functions, combinations of functions. And we talked about adding when we had like f plus g of x, and it could be rewritten as f of x plus g of x, right? And we did it with multiplication, we did it with addition, subtraction, multiplication, but we hadn't yet gotten to division, right? So we are going to start with division or quotient, which when I have the quotient, it's like saying f over g of x equals f of x over g of x. And you're thinking, ooh, that looks like it might get really complicated. And if I was asking you to reduce it all, it would. But literally, it's just writing whatever f of x is over whatever g of x is. The only difference is we have to know the domain, of those functions. So if I am finding the quotient, you need to go away. I don't want them to see you yet because you are the super cool thing that I am sharing later.
You showed it.
They don't know that. They can't read it yet. My face is in front of it.
Did they get the gist?
No, they don't. They don't
I
have
see
any
it.
gifs.
I can show them.
Well, you can see it on the board. It's my favorite poster ever. So when we're finding the quotient, of two functions, finding the quotient of two functions, and I have an f of x that equals the square root of x, and I have a g of x that equals 4 minus x squared, the square root of 4 minus x squared. All right, when I'm looking at this, I want to find, you're going to find f of g of x, and we're going to find g of f of x. Oh, shoot, no. Oh my gosh. No, I don't know why I'm doing all that. I'm moving into the composition before I need to. Don't worry about any of this yet. I don't want to scare you with that because we're going to do it later. See, I'm off my game. We just want to find f over g of x, and we want to find g over f of x. Well, it looks super complex, right? But it is not, because what we do know is that f of g of x can be written as f of x over g of x. What do we know f of x is? Well, it's the square root of x. What do we know g of x is? Well, it's the square root of 4 minus x squared. Literally, that's it. Right? That is literally it. The only thing is we need to know the domains of these functions. Like, what can x be? Now, these are square roots. So whatever it has to be 0 or greater. Right? And we know that our denominator can't be 0. Right? So if I look at this, if I look at the domain of x, f of x, like the domain of f of x would be anything 0 and greater, right? It could be 0 and it could go all the way to infinity. It can't be a negative because a negative under a square root is imaginary. If I looked at the domain of g of x, I'd be like, same thing. Well, what's going to make it 0? 2 would make it 0, right? 2 squared and negative 2 squared. Anything else would make it negative. So I can't go bigger than negative 2 to 2, right? So this is the domain of f of x. This is the domain of g of x. The domain of f over g would be, well, what makes this 0? What makes this 0? Because this can't be 0. So it's going to be, excuse me. This one, it can go anywhere from 0 to 2, right? But it can't include 2. And if I put 0 in here, I get 4 minus 0, which is 4. If I put 1 in there, I get 4 minus 1 squared, which is 3. If I put 2 in here, though, I get 4 minus 2 squared, which is 4. 4 minus 4 is 0, and it can't be 0. So it can go up to 2, but not include it. So I am not going to pay a lot of attention to the domains. I just want you to understand that it can't be everything, right? So the domain of f over g is that one. What about g over f of x? It's literally 4 minus x squared over square root of x, right? Super, super easy stuff. The only thing that x can't be in this is 0, because that would make it 0. So our domain would be 0 to 2, right? Y to 2, because this one also can't be less than 0 because it breaks the rules. Do I care about the domain? Not a whole lot. But I do want you to kind of understand what it is, right? It's just saying, what can x be in these circumstances, right? What is it allowed to be? But ultimately, what we want to see is that you understand that it's f of x, whatever f of x is, divided by whatever g of x is, which is why I'm not spending a lot of time on quotient, because it's really, really basic, right? I mean, it's the simplest thing we've done so far because there's no actual operations involved in it. But where we're going to be spending our time here is in the composition of functions. And then the composition of functions means one function, go away for right now. It's not your time yet. The composition of functions means that we are composing one function with another function. It's saying composition of functions. I love compositions of functions. Now, the definition, by definition, is the composition of a function of f of a function f with a function g is this. It says that, ooh, you're going to love this because it's a lot of symbols. F of g of x equals f of g of x. What does that mean? What does that mean? If you remember, if I have f of x, right? Say I just have plain old f of x, it means that's what we're inputting for is x, right? If I have f of g of x, that means wherever I have x, I'm putting in whatever g of x equals. Now, what does that look like in reality? Well, here's the best part. I have a picture form of it using Bugs Bunny and Stalin. This is my favorite poster ever, right? So if my f of x equals Bugs Bunny, right? Bugs Bunny is f of x, and Stalin is g of x. And so when we have f of g, it means whatever g is getting plugged into whatever f of x is, right? We are taking Stalin and plugging him in to Bugs Bunny, right? G of f of x means that we are taking Bugs Bunny and plugging him into Stalin. So this is f of g of x. This is g of f of x. That's the basics. What does it look like mathematically? It doesn't look nearly as cool as Bugs Bunny and Stalin. Which, by the way, this is my favorite poster ever. I made it myself, and it hangs on the whiteboard in my classroom, and I will have it forever because I think it's the coolest example of composition of functions. Mathematically speaking, if I am given an f of x that equals x plus 2, and I am given a g of x that equals 4 minus x squared, and I am asked to find f of g of x, or I am asked to find g of f of x, or I'm asked to find g of f of negative 2. We're going to look at this, and all we need are these two functions right here that we're given. F of g means whatever f is, we're going to plug g into its x value. So my f of x in this case is x plus 2, right? So f of g means wherever this x is, I'm going to plug in whatever my g of x is. So here I have x plus 2. Well, where the x is, I'm going to plug in 4 minus x squared plus 2. And then we're just going to solve it out, right? Well, there's nothing to distribute or anything like this, so it really becomes 4 minus x squared plus 2. Here I wind up with negative x squared. 4 plus 2 is 6. That's it for that, right? I'm just combining those two things. Here I have g of f, which means that, let me rewrite this so it's not circled anymore. So here I've got my 4 minus x squared. Now wherever I have x, I'm going to plug in x plus 2. So here I have 4 minus x squared. Well, that becomes x plus 2 squared. Does that make sense? We're plugging Stalin into Bugs Bunny. So x plus 2 squared, we can solve it out if you want, but really, or I could just tell you that it's 4 minus, it's like saying x plus 2 times x plus 2, right? And I can FOIL that out, and I would wind up with 4 minus x squared plus 4x plus 4. My pocket's ringing. Oh, it's Scam Likely again. It's the best boyfriend I ever had. Now, here's the thing. This minus right here has to be distributed, right? Because we're saying minus x squared, but we're also saying minus 4x minus 4. And so this becomes 4 minus x squared minus 4x minus 4. And now we can just combine our like terms. Well, there's no other x squared term, so it's just minus x squared. Then we have no other x term, so it's minus 4x. 4 minus 4 is 0, so this is it. This is our solution. Boy, he is like, first he was calling from Temecula, now he's calling from Texas, but he gets around that scam likely. And so we have solved these two out as much as they can be. But now if we look at part C, it's asking us for g of f of -2. But we know what g of f is, right? We just solved that g of f of x equals -x squared minus 4x, right? We just solved that. We know what that equals. So g of f of -2 means that we're just going to plug -2 in where there's an x here. Keep in mind, when you are plugging something in to a function, put it in parentheses so you remember how to properly do that. We have negative x squared. Well, that becomes negative times -2 squared minus 4 times -2. Everywhere there was an x in here, I put in a -2. -2 squared is -2 times -2, which is +4. But we still have this negative on the outside, so it's going to become -4. -4 times -2 is +8, and we just wind up with 4. Does that make some sense? You guys probably did this a little bit in Algebra 2, composition of functions. They probably did not have Stalin and Bugs Bunny. The chances of them having that were pretty slim, although I might have shared it with Mrs. Valdez. I don't know if I have, but had I, you might have gotten it that way. I do have other examples. What I don't have is a lot of time because this class ends in like 8 minutes. So I am happy to show you another example of it or put one up for you to find if you'd like to see it. But if you don't want to see it, I'm not going to require you to stick around for it because time is limited today. I have not put up the WebAssign assignment yet. It'll be put up before I leave school today. But I have a student that I want to onboard here before I get going. So I want to give you guys the chance to leave a few minutes early. David, if you could stick around so I can take you through the ins and outs of the class, that would be great. Any questions? Anyone want to see something? Anyone want to go away? All your call. Jasmine's good. That is fine, Star. I know sometimes you have to play with stuff a little bit before you know whether or not to do it. That's going to have to be in tutoring time, the stuff about the unit test. Shoot, I don't have any today. I do have a little bit of time at like 2:05 if you want to meet me in a Google Meet right around then. I have like 10 minutes before I have a meeting. Okay. Yeah, meet me at about 2:05, 2:10. I'll send you an invite. Writing that down so I remember to send. Yes, sir.
So, am I allowed to go?
Yes, you are allowed to go.
I can. Let's go. I'll see you.
I will
Friday.
get those extensions in today,
I'll see you
Bella. Are you a Bella or are you a Issa? Or are you Isabella? Do you not shorten it? No, I'll just send you an invite and you'll just be able to click from there. I know, but what do people call you? Bella? Okay. Then that's what I'm going to call you. And David Lopez, you can go if you want to. I was talking to David Castanon. I don't know if I said that right. Castagnon? 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 So, David, I just wanted to ask you if you have any experience with Power School at all. Have you used it where you were?
No.
Hold on, let me stop